Greetings and welcome to the first part on a new series on matrix. The first three parts of this series will be covering the O-level syllabus to help students revise this topic during the COVID-19 pandemic. The success criteria for part 1 will be for students to be able to find the order of a matrix, determine when matrix addition or subtraction is admissible, and to add and subtract matrices. But what is a matrix? To quote Morpheus, the matrix is everywhere. It is all around us. Even now in this very room, you can see it when you look out your window or when you turn on your television. But seriously, what is a matrix? In the basic level of math, a matrix is just a rectangular array of numbers. One useful application of matrices is that it stores numbers that you might normally find in a table form. Have a look at this Premier League table. Just before the league was suspended, Liverpool was on top of the tables with 27 wins, 1 draw and 1 lost. We can turn this table into a matrix. In a matrix, each of these numbers is called an entry. The entries in a matrix are arranged in rows and columns. Rows are the horizontal list. In this given example, we see 4 rows. Columns are the vertical list of numbers. In this example, we see 3 columns. Every matrix has an order. The order is defined by the number of rows by the number of columns. This cross-like symbol here does not mean multiply. We read it as by. Just like when you say the dimensions of a room is 4 meters by 5 meters. We don't multiply those two numbers together. In this given example, the order of the matrix is 4 by 3. Let's check your understanding here by having you state the order of the following matrices. Pause the video here and give this question a good try. Let's go through the answers. The order for part 1 is 2 by 3. For part 2, it is 5 by 2. And for part 3, it is 6 by 4. The matrix in part 3 is particularly interesting in the sense that every entry in this matrix is 0. We call this special type of matrix a null matrix. Moving on, for addition and subtraction of matrices to be possible, the order of the matrices must be the same. Let's look at some examples. Let's say I want to add these two matrices together. Well, they are both 5 by 1, so that is perfectly possible. But if I want to add a 2 by 3 with a 3 by 2 matrix together, that is inadmissible, which means to say that it cannot be done. It is undefined. So let's actually try to do the addition. But before we begin, let's make this question a little bit harder. Now, addition and subtraction, they operate on the entries found in the same rows and the same columns. So for the first entry, we can take 3 plus 2 minus 1. We repeat this for the other 4 rows. Computing each entry separately, we get this answer. Notice that addition and subtraction always preserves the order of a matrix. Let's move on to a worked example. How do we evaluate the addition and subtraction of these 3 2 by 2 matrices? To make this easier to follow, I've colored the numbers in the first row, first column as red. The first row, second column are colored green. The second row, first column is colored blue. And the second row, second column is colored purple. So to evaluate just the entries in the first row, first column, I bring all the red numbers together. I get 3 minus 6 plus negative 1. And the same is repeated for all the other 3 entries. Evaluating each entry separately, I get this as the final answer. Now, some additional practice for this topic can be found in the info section. I've attached a link to the worksheet for extra practice and a solution sheet for you to self-check your answers when you are done with the worksheet. Before we end, let's reflect on today. Are we now able to find the order of a matrix? Are we able to determine when addition and subtraction of matrices are possible? And are we able to add and subtract matrices together? We have come to the end of this very quick introduction to the world of matrices covering order, addition, and subtraction. Stay tuned to the next part of the series where we will cover matrix multiplication. But for now, thank you and have a good day of learning.